Hey, my name is Dhruv and I'm a tutor at Tutor Here. And this video is just to give you an introduction about physics and what do basic things like vectors and scalars mean. So let's get started. So a few hundred years back, people, I think, started thinking generally that why am I alive? What is the nature of my existence? What does reality mean for me? And how do these things around me just fit together? How do I fit together in this world? And those questions, the answer to those questions is why a subject like physics was created. So when we think about physics right now, people who have never been accustomed or never heard about physics would just think about, okay, it's something related to space, which is something right here, a galaxy or something, or a rocket, or let's say this rainbow. It's explained by something which is a physical phenomenon, something that you can't explain without science. But physics is actually at the core of all sciences. So let's start with math. Math is completely logical and fundamental. And throughout your mathematical journey, you might think, why am I learning this math? Like, where am I going to actually use it? And physics is the best place to use math to explain this whole universe. And trust me, when you fit math and physics together, it explains everything. It just glues everything together to make complete sense of this entire universe. Let's come to subjects like chemistry, something as basic as an atom. So just think about it. If I have a piece of wood in my hand and I try to break it, I would need to exert some force. Now, why is that there? Why is it hard to break a stick? It's because the molecules inside exert some force on each other so that they stick together. There is some force there, and force is a part of physics. So you have physics, which is at the base of chemistry. When you think about our human body, our neurons and everything, this is all related to physics and chemistry. So physics is not just about explaining complex phenomena, it's actually present at every point of your life. All right, so let's go ahead. All right, before getting into scalars and vectors, we have come up with a measurement system. Let's say I take a scale, I can measure up my own height. I may be around 5'11" maybe, all right? So I can measure that. I have some measurements for myself. Now there are a few ways you can measure something, all right? So let's look at these two people who are actually measuring something. So here is the first guy, all right? He is holding a sign which says 5 meters long, all right? Now this is giving you a quantity. What is that quantity? That quantity is 5. It's saying it's 5 meters. So you've also got your unit and it's saying it's long. So it's 5 meters long, all right? And here we have another person who's standing with a board and that says 5 meters east. Now, when you look at this the first time, what is the obvious difference between these two? And you're right, it's that this guy is saying east, whereas the other guy is saying long, okay? So the common denominator for both these people is that they've written 5 meters. 5 meters, can I call 5 meters as the size? All right. So it is the size. All right. This size is also referred as magnitude. All right. So we can refer 5 meters, 5, the quantity 5 as the size or a magnitude. And this is common for both these people. All right. Now, where it comes to be different, this person, scalar, is saying that it's long. Long can be anything. Long can be like this, like this, like this. You just don't have a direction. It's just saying something like 5 meters. That's it. When you come to the vector, it's saying east. Now that's a particular direction. So you have directions anywhere. This is the direction. This is the direction. This is the direction. And it's specifying that it's on the east direction. So 5 meters east. All right. So something extra with this vector is something called the direction. So we define a quantity, which is a vector, as something which has both size and direction, all right? And we define scalar as something which is only size. Size and magnitude are synonyms, all right? So scalar is something, scalar is the measurement of a quantity which just has the size or the magnitude, and vector has both size and the direction. Is that clear? So let's go ahead. All right, so let's actually build a little more of this logic, okay? let's assume that there is a box lying on this road, all right? So this is a box lying on the road, and let's say I move it ahead by 10 meters, all right? Here's the box, I move it ahead, and this is 10 meters, okay? Now, if I think, okay, I am moving this box 10 meters in 5 seconds, all right? I move this box 10 meters in 5 seconds. What is the rate at which this box is moving forward? And if you've studied stuff like speed or velocity, you can easily calculate it and say, okay, the rate at which this box is moving forward is the speed divided by, sorry, it's the distance divided by a total time. Am I right? Let's just change the color for this. Let me put it to green. All right. So it is the distance, which I represent by d, divided by the time. All right. It will be 10 meters divided by 5 seconds. Yes. 5 seconds, which will be 2 meters per second. All right. 2 meters per second. All right. Now, when I look at this quantity, okay, when I look at this quantity, is this a scalar or a vector? What do you think? I see that this is looking like it's saying that the box is traveling 2 meters per second. But is it traveling in this direction? Is it traveling in this direction? This direction? I just don't know. So I say that this quantity is a scalar, all right? And this is speed. Speed is a scalar quantity, which is just telling you the magnitude or the size, and it's saying this box is moving at a speed of 2 meters per second, all right? Now let's say I say that this box is moving to the right. This box is moving to the right, all right? This box is moving to the right. It's moving to the right. How much? It's moving to the right 10 meters. And how much time did it take to complete those 10 meters? It was 5 seconds. So again, to calculate the rate at which this went, let's do distance upon time again. All right, distance upon time. And this would be 10 meters right, 10 meters right. So if I want to represent that it's going right, let me just denote that by an arrow. All right, this arrow is saying that it's moving towards the right, and I divide it by 5 seconds. All right, so my final answer would be 2 meters per second. And I can put this bow, I can just write towards the right. All right, towards the right. Okay, so now what is this quantity? Is this quantity a vector or a scalar? And you would be right to point out that this is a vector because I have my magnitude here and I also have my direction, which is that it's moving towards the right. And this quantity is called velocity. Velocity, all right? And it's represented by this arrow because it's a vector, all right? So here's the difference between speed and velocity. Speed is a scalar quantity. Velocity is a vector quantity, all right? There are also some other subtle differences like distance and displacement, which we can cover in the next video. But for this video, let's just end on this note that physics is at the core of everything. Something like a force, which is also a vector quantity, is calculated by mass into acceleration, all right? Everything is at the core of physics. You have something like force, you have something like displacement or distance, you have something like velocity, change in distance upon change in time. So everything is physics-centric, and this is the start to your journey to understanding physics. So I hope you had a good time over here, just learned a few basic fundamental concepts of how important physics is and how important scalar and vector quantities are. So thank you so much for watching this video. If you have any doubts or any comments, please leave them in the comment section below, and I hope to see you next time. Thank you.